How are we going, guys? So, yeah, Kat Gill, PhD student at UWA, and we've obviously seen a lot of evidence today that we probably have older crust happening within the southwest terrane. Let's take a look at some of it. So my PhD is focusing on basically looking at this new boundary between the southwest and the Uwami terrane that was defined as part of the AGP project. So you can see here, here's a bit of the older boundary and that new boundary coming through. My project area, as we can see here on the left, straddles that boundary directly, covering the areas between roughly 2J and northern and that sort of supercrustal sequence that we see there. So as of the beginning or middle of last year, I'd done a lot of field mapping, structural work to try and pick apart and give another look over some of the maps that we had there historically. And I was able to define sort of a history of two main stratigraphic sequences, as well as a late stage deformation characterized by about 3 generations of folding. This includes early isoclinal folding, a later stage of upright folding that we call F2, and then all this is overprinted by shearing from the terrane boundary. And we can see that rotation there in the interpreted geology, where all of it just comes into parallelism with the terrane boundary. And all these earlier relationships we see over here to the west are completely lost. And this is what some of that earlier folding looks like in the field. Your early F1 isoclinal folds with your upright F2. So as you can see, we've got some rough dates on here, and that is defined by previous work, such as Simon Wild's stuff. Coming forward, we've tried to constrain some of this stratigraphy by coming in with some geochronology, mixture of some detrital and magmatic samples from 2 main areas. The first one being Poison Creek, which is just in the western area of my field area, and the second is just way up the north here in a little area called Crustal Reserve. And these are the outcrops that we see there. Now, Poison Creek is where we sort of see the type locality for the stratigraphy that we see in this area surrounding 2J. We have a nicely preserved, overturned sort of synclinal fold that we can see sort of preserved, and we can see our facing indicators in relict cross-bedding and that within the quartzite. And most importantly, what we see is a relict unconformable contact between 2 of the metasedimentary units. That is seen here in the bottom, where you have the bedding of the quartzite, which is truncated by a relict sort of erosional contact you see here, telling us that the sequence is overturned, but it gives us an important stratigraphic relationship between the 2 units. And so when we did the geochronology on this, we got a maximum depositional age of 2699 from this younger unit here, the metasedimentary rock, which would have unconformably overlain the quartzite. We got a maximum depositional age of roughly 3.2 from the quartzite. But when we went back and dated the magmatic age of this orthogneiss, which is within layer parallel sort of things with relict igneous contacts, so we interpret it to be a relict igneous intrusive into the quartzite, that came back with a magmatic age of 3246, which tells us that the minimum age, therefore, for the quartzite should be 3246. We don't know what the maximum depositional age is, obviously, because the peaks in the detrital spectra that we were getting don't actually match up that well, which we can see here. So what you can see here is that is the Concordia showing a Concordia age for 3.2, 3246 GA. And then down below we see here the detrital spectra for the detrital analyses that we did. This younger metasedimentary unit here has a single peak in the data, giving a maximum depositional age of 2699. And then here is the detrital spectra for the quartzite. We can see we've got this main peak at the same age of the orthogneiss at 3246 roughly, and an older peak sitting here at 3400. Something about this is definitely related to this orthogneiss, I reckon, and some of the peaks that are in here don't line up with the constraining ages from the orthogneiss necessarily. And then we come to Crustal Reserve. Now, this is the outcrop I found. It is significantly more deformed than the quartzites and the orthogneiss and the metapelite that you were seeing before. We have evidence for partial melting textures and destruction of the gneissic textures happening in there. And so we sampled 2 spots from this outcrop for geochronology. The melanosome sort of gneissic fabric, the origin, and as well the leucosome from the partial melting that was coming off that. And these returned an age of 3417 MA and 3246 MA, respectively. So this identifies a previously unknown component within the southwest terrane sitting at 3400 GA approximately. And then the age of melting within this migmatite, or an age of melting, there's many components there, comes up equal to the orthogneiss which you're observing in Poison Creek. So if we start to compare this with other areas of the Yilgarn Craton, which we have the closest representative, which would be the Urarta gneiss from the Narrier terrane, which still trends a bit older. The gneiss that we've identified in the southwest sits somewhere between the Dougal gneiss and the Urarta gneiss, wherein you have the Urarta gneiss simply 3490, whereas this is close to 3420. And you can just see the comparison there. And then if we look at the detrital spectra for the quartzite that we see in the southwest terrane, these are previous studies comparing the thing. Our data lines up pretty much exactly with what has already been done. And we can see that the southwest terrane detrital spectra is missing a lot of the older peaks which we see happening in the Narrier, as well in some of the the Uwami terranes where we do start to have those really old, almost Hadean age zircons. And so that starts to question sort of where the southwest terrane fits within the crustal evolution of the Yilgarn Craton, because currently, as it stands, we haven't seen any clear correlative magmatic units or source material that matches with what we see in the southwest. So as an updated thing, now that we've constrained our sort of stratigraphy and history for this area a bit, we can now put in our two magmatic events, which we see here, the igneous precursor to the Kundal gneisses, which we presume acts as basement, to the 2J quartzite, well-known unit, which was then intruded by the precursor of our orthogneiss, all of that which is truncated by our unconformity, giving our P-light, which we saw in the Poison Creek, and then our updated. So by doing this, we've basically added a much older age to the southwest, pushed back that history of crustal evolution, and much more tightly constrained our stratigraphy. Thank you.